We got an endpoint and a midpoint, right? We got to find the other endpoint. Well, I know that my midpoint is what I usually solve for in the midpoint formula. So if I call this first... What's happening? Oh, okay. That's what I figured. So if I call my first endpoint x1, y1, I could say negative 7 plus x2 over 2, comma, negative 1 plus y2 over 2. So that's like my little setup here, right? Now, what I want to do, I don't know, I'm not sure if we did this in the notes, but I'm going to split it up into two equations. Is that what we did?
Yeah.
Yeah, we did. Okay. So let's solve for x first. I know that my x has to be 7. Negative 7 plus x2 over 2. Right? And I'm just solving for x2. So I'll multiply by 2. I get 14. And then I add 7. And I get x2 equals 21. Right? Then I'll set up for the y. I'll say 6 is equal to negative 1 plus y2 over 2. I'll multiply both sides by 2 to give me 12. I'll add 1 to give me 13. So now I have my x2. I realize there's not a whole lot of space here. That's my bad. I got my y2. My endpoint is at 21, comma 13. Give me a thumbs up if that's what you got for number 5. 21, 13. Yeah, Arish, great. Aldrich, Abigail, good. What do my endpoint and midpoint have in common in number 6? The same numbers? Which number is the same? The y's are the same. Okay, I've got negative 6 and 6. Well, if this is a line, right, and my midpoint and endpoint both have a y value of negative 6, I know that my other endpoint must have a y value of negative 6. That's half the work done right there. We don't have to set up that part of our equation. What we can set up, if my midpoint is at, let's say this is just for the x. My midpoint's at negative 8. I know that's going to be x1 plus x2 over 2. Right, so this is just my x side of things. I'm going to multiply by 2. I get negative 16. I'm going to subtract 8, and I get negative 24. So my point, negative 24, negative 6. There's my other endpoint right there. Right, and this makes sense. If my endpoint is at 8 on the x-axis, my midpoint's at negative 8, how far away are those 2 points in a direct line? 16 spaces away. So if I subtract another 16 spaces from my negative 8, where do I land? Where do I end up? Negative 24. Right? So this is a, well, let's see, 8, negative 6, negative 8, negative. This is a horizontal line, right? So if I'm in a horizontal line, I can just count. My change in x is minus 16. So I know that from negative 8 to my next one is going to be another minus 16. But this only works if we have a horizontal or vertical line, right? Exactly, like what you did, kind of. Everyone good on number 6? Does that look okay?
Yeah.
For whoever asked for number 6. Finally, number 7. Is this going to be a horizontal or a vertical line? No, the x's are different, the y's are different. So we got to set this up. For my x, I'm going to say that my midpoint, negative 10, is equal to x1 plus x2 over 2. And for my y, I'm going to set up that negative 6 is y1 plus y2 over 2. Multiply by 2, multiply by 2, I get negative 12. Breezing through this here, times 2, negative 20. I'm going to add 9, x2 is negative 11. I'm going to add 3, y2 is negative 9. So negative 11, negative 9 is my other endpoint there. Give me a thumbs up if you got that for number 7. Okay, that makes me feel like I'm doing it right, which is good. What'd you guys get for number 8? -3, -10. Is that what you guys got? Yeah? I'm not going to do it, but if you all got it, must be right. All right? Flipping over to the back, number 13, we got to find RQ. Now, again, this is what I said yesterday. Do these two mini segments, SR and RQ, do they look congruent just at first glance? They do, right? But if I'm adding 16 to one and 17 to the other, I know they can't be exactly the same because that wouldn't give me the same number. So I'm going to set up an equation. This is going to play into what we're doing tomorrow as well. I'm going to set up an equation here where SR plus RQ is equal to SQ. Right? That means this segment plus this segment equals this whole thing. Well, I know the whole thing is 17. Do I know what SR is equal to? Yes and no, right? I don't know what number it's equal to, but I know that it is equal to x plus 16. Do I know what RQ is? X plus 17. Look at that. We're back in our very first unit of the year where we're solving equations. What do I want to do on the left-hand side here? Do you guys remember what it's called? Combining like terms. I got two x's. I'll call that 2x. I got 16 plus 17. What does that give me? 33. I'll subtract 33 from both sides. And that gives me negative 16. Divide by 2. And I get x equals negative 8. Is that my final answer? No. What is the question asking? Find RQ. RQ is not negative 8 units long. That wouldn't even make sense. How can something have a negative distance? It can't. So I'm going to take the expression that RQ is equal to, and I'm going to plug in negative 8. What's negative 8 plus 17? 9. 9 what? Units. There's my length for RQ. If RQ is 9 units, how long is SR? 8 units. Do 9 and 8 make 17? Yeah. If we can see by these expressions that RQ is going to be one more unit longer because it's x plus 17 compared to x plus 16. And that's why they look congruent, because they're only one tiny unit off. But again, we can't just assume by looking at a diagram that something's congruent. This is something that is going to go on forever in your math classes. When you get to like triangles and trigonometry and calculus and all that stuff, if you look at something and it does not tell you these things are equal, you cannot assume they're equal. If I gave you a triangle that looked like this, what type of triangle is this? Right triangle. How do you know? Is there a square there that tells you it's 90 degrees? No, then it's not a right triangle. You see what I'm saying? If I put this there, oh, now it's a right triangle. Right? You can only assume, or you can only use the information that's directly given to you in the problem. You can't make assumptions, right? So if that little square is in there, it could be a right triangle, but it could also not. What's that? What'd you say?
Never judge a book by its cover.
That's right. Never judge a triangle by its corners. All right, JK. Here I'm going to find JK. I get set up negative 8 plus x equals my big one minus my other little segment. Some of you may have set it up differently. This might be the first step after the way you set it up. I'll just cut a corner right there. 2x minus 20. I'm going to subtract x and add 20. And I get, oops, sorry, I crossed out the wrong thing. X equals 12. Is that my answer? No. JK is negative 8 plus x. Well, what's negative 8 plus 12? 4 units. If JK is 4 units and IJ is 9, how long is IK? 30 13. What were you going to say, Liana?
20 because you add 11 and a 9.
Are you confused with how I set it up? Perfect. So what a lot of you probably set up is, hey, this big section equals the left side plus the right side. Is that how you set it up, Liana? Yeah. So then what would you do? Well, you would subtract, or I guess you would combine these and subtract it, but if I subtract 9 from both sides, I get 2x minus 20 equals negative 8 plus x. It's the same thing. So you could set it up as, hey, the big segment equals little plus little, or because I want to find JK, I set it up as, okay, what I want to find, JK, is what's isolated. And I know that JK is the big segment minus the segment that I know is 9. It's the same thing, though. You still look confused. Does that kind of make sense or no? All right. Well, did you get the same answer 4?
No.
I'll take a look at it in a second. Any other questions I can answer about this? All right. Do me a favor. If you're done with it, pass it up and take your notebooks out. You guys ready to have a fun lesson today? I think it's fun.
Yes, it is.
We get to draw on something, kind of. What did you get?
I got
10. Can I see what you did? For this one, right? So you said 2x minus 11 equals 9 plus negative 8 plus x. 9 minus 8, I assume that says a 1. Okay. It's 1 plus x. I subtract x and x. I add 11, and 1 plus 11 is 12. Yeah, that's okay. Half of Fix it already.
in my mind.
Sweet. It's pretty much 360 middle school. Yeah, it looks like a menu. Is there a menu that you have? I've never seen those menus. So. Give it up. Do you need it? Sure. How do you keep it all together? Alright. I have notebooks if you need a notebook. Just let me know. Anybody know what this is? What is this?